So the poster section will begin at 2 p.m. And the panel that's supposed to happen about pterosaur and science communication, as you may notice, Darren Nash didn't make it. So he had a flight problems and he had to come back to England. So we will change this panel to a discussion about fossil repatriation. So people will come and we will discuss about that. And after this panel will begin at 4, we will have our closing session, okay? So Rafael, if you want to start.
So good morning. Let's officially start our second day of presentation. The first person to present is Rodrigo Pegas, and the title of his presentation is Comments on the Iwaki tupuxuara specimen and the taxonomy of Thalassodromidae.
Hello. Yes, it's working. Hello, everybody. Good morning. So, my name is Rodrigo. I am a PhD student under the supervision of Professor Fabiana, who is sitting right there, at the Federal University of ABC in the state of São Paulo. And this morning, I am going to talk about the Iwaki tupuxuara specimen and make some comments about the taxonomy of Thalassodromids. So, what is this about? For those who are not quite familiar with pterosaur families and diversity, Thalassodromids are a very small group of pterosaurs, and they are characterized mainly by this very large frontoparietal crest, who is directed posterodorsally on the skull. Okay, so this is the skull of tupuxuara in right lateral view. Let me just put my timer on so I don't go ahead of time, because if you let me, I can talk about pterosaurs for hours. Let's not let that happen. And besides the very large cranial crest that projects posterodorsally, they also have a very interesting feature, which is a palatal queue. So these are asdorcoid pterosaurs, so like every other asdorcoid pterosaurs, they also lack teeth, which is also an interesting feature. So this group, Thalassodromidae, was named by Kenner and Campos 2007. Pretend this is a 7, okay? 2007. And there is a small nomenclatural problem with this group, because in some papers you are going to see authors referring to this group as Thalassodromidae, and other papers are going to refer to this group as Thalassodrominae. Whenever you see either one of these two names, remember they are talking about the same group. If you follow the phyllo code, as is my case in this presentation, you need to use Thalassodromidae because it was registered first, excluding, with Tapejaridae excluding Thalassodromidae. But if you follow just the ACCN, you can choose between Thalassodromidae and Thalassodrominae according to your preferred phylogeny. So Thalassodrominae is usually used when this group is considered to be the sister group of Tapejarinae. But if you follow the phyllo code, you can use Thalassodromidae either way. So in this presentation, we are also considering them as the sister group of Tapejaridae, but both at the family level. So it's just nomenclatural issues to make to clear things up, so that you guys can remember when you're reading a paper that either one of these words are going to refer to the same group. Just to keep that in mind, because pterosaur nomenclature is very complicated, so it's always nice to make some reminders. And so, like I said, this is a very small group. It includes just 3 genera: Tupuxuara, Thalassodromius, and Careridraco. And all of these genera come from the same formation, the Romualdo formation of the Santana group here in Araripe. The first species to be described was Tupuxuara longicristatus, which is the type species of Tupuxuara, by Kellner and Campos, 1988. As you can see, this is the holotype, okay, of Tupuxuara longicristatus. It's a fragment of a rostrum. So this is a schematic drawing from the original paper. As you can see, it preserves the anterior margin of the naso-antorbital fenestra, and it's lacking the very tip of the rostrum. And we can see developed premaxillary crest. It's slender and tall, and we can see the palatal keel, which, like I said, is very characteristic of thalassodromids. And a few years later, we had the description of a second species of Tupuxuara, which is Tupuxuara leonardi, which is also a fragmentary rostrum. Now, this is just the a rostrum portion without the anterior margin of the naso-antorbital fenestra, and it's very similar. It also has a similar premaxillary crest and a similar palatal keel, except that this palatal keel is much more robust than in the previous species. And then, besides from the holotype, we also have the Iwaki specimen. The Iwaki specimen, it was reported by Kellner and Hasegawa in an abstract, and then the skull has been figured and mentioned briefly in several occasions, such as these ones. And so it's a very nice specimen that needs a full description, because it has been mentioned several times but has never been described in detail. And it preserves a lot of skeletal parts. In this image, the legs are mirrored. It only has one leg, not both legs. But if you take into account all of the elements, you can find the complete wing and also the complete cervical series, besides the femur and the tibia and the skull, and also the sternum and notarium. And besides Tupuxuara, then we had Thalassodromius, described by Kellner and Campos 2002, which is represented by this very large, almost complete skull. And then we have Thalassodromius oberli, which was described as a new genus called Banguela, which was thought to be a Zungaripterid. But then, before it was described as a Zungaripterid, it was already described as something like Thalassodromius, and then it was described as a Zungaripterid, and then it came back to Thalassodromius. So it's up to debate, but not many researchers have given their opinion about this, actually. And then we have Careridraco, which is the last one and the most recent one, which you saw 2 days ago in the museum in Santana, which is represented by this partial skull. So, what is the problem I want to talk about today with thalassodromids? There has been a series of taxonomic disputes. Martin and Nash, 2006, they suggested that the 2 species of Tupuxuara and Thalassodromius, they would be a single species, and that Thalassodromius would be the old adult morph of Tupuxuara. So these 3 species would actually be a single one. The problem with this is that as pointed out by Keller and Campos the following year, there are strong differences between Tupuxuara and Thalassodromeus that were not accounted for. As we can see in this image, for example, in palatal view, the holotype of Tupuxuara longicristatus, Tupuxuara leonardi, and the Iwaki Tupuxuara, as you can see, after the palatal queue, the palatal surface is convex, and in Thalassodromeus it is strongly concave. So that is one of the main differences that was pointed out in this paper, among other ones. And so after this paper, everybody agreed, even Martin and Naish agreed that they are very different, and the synonymization between Thalassodromeus and Tupuxuara was set aside. However, the synonymization between the two species of Tupuxuara between themselves, apart from Thalassodromeus, was still clouded. Some researchers like Wheaton, 2009-2013, they considered them as different, but the abstract by Villanova et al. 2014 still considered them as similar, probably synonyms. So this is a good question. So here, in 2019, this is Fabiana, who is sitting right there. We went to Japan to see the specimen, and our main objectives are to provide a detailed anatomical description of this specimen, because it is very important. It has been mentioned, like I said, so many times, and it has never been described in detail. And also to make photogrammetry, to use it in biomechanical studies. So here you can see, for example, a 3D model of the skull, and here of the wings. So, what can we say about this specimen? We can describe it in detail to provide updated comparisons with other thalassodromians. So, about this problem, about the distinction of these two species, Tupuxuara leonardi and Tupuxuara longicristatus. Originally, when these two species were proposed and compared in details, there were 3 proposed differences concerning 3 features: palatal keel robustness, palatal keel extension, and the foramen on the wing phalanx close to the extensor tendon process. In Tupuxuara leonardi, the palatal keel is very strong concerning robustness. Concerning extension, it is restricted posteriorly, and the foramen on the wing phalanx, the first wing phalanx, would be absent. And concerning Tupuxuara longicristatus, the keel is much more slender, it's much slenderer, and it's more extended anteriorly, and the foramen would be present. The third difference can already be set aside because, as already pointed out by Keller in 2013, the Iwaki Tupuxuara does have this feature, so they don't differ in this feature, but they still differ in the other 2. So, concerning palatal keel robustness, as you can see, when we look at this rostra in lateral view, this is the Iwaki specimen, okay? So this is the keel, it's very strong. You can see it in lateral view. The same situation occurs with the holotype of Tupuxuara leonardi, and the holotype of Tupuxuara longicristatus is very different. It is imperceptible in lateral view, and we can see it better in occlusal view, in palatal view. The situation is this. As we can see from Anhanguerites, these specimens, these Anhanguerite specimens from the Romualdo Formation, they suggest that maybe the robustness of the palatal keel is could be an ontogenetic feature. So we can see, for example, the very juvenile specimen described by Duque, who is here somewhere, there. A very slender palatal keel, almost imperceptible. And then when we see older specimens, such as the subadult Anhanguera from the AMNH, it is much more pronounced. Of course, this is very hard to be certain of because of taxonomical problems. Is this Anhanguera? Is this not? How many species of Anhanguera there are? But still, it's interesting to see that there is a pattern where older Anhanguera specimens, irrespective of taxonomic problems, they seem to have more robust palatal queues than the smaller ones. So could this be related to ontogeny? Concerning the extension, when we superimpose the Longiclistatus specimen with the Iwaki specimen, we can see that this is, how can I say, deformatado. It's out of format. Please imagine, let's use our imagination. Please imagine that this is right here, showing the height of the rostrum right in front of the nasoorbital fenestra, and the blue line shows the extension of the palatal queue. So these two specimens are very similar concerning the palatal queue extension when we superimpose them, and the holotype of Tuposhara leonardi we don't really know. So what does this mean? There would be a single difference between these three specimens. The only difference is the palatal queue robustness. So I would like to leave the question, could this be ontogenetic? Could they be a single species? So, like I said, this raises these possibilities. And aside from that, which is what I wanted to talk to you about, the detailed description of the Tuposhara specimen also allow us to make updated comparisons with the Thalassodromios. See more, you guys can check that on the expanded abstract on the book. I will not bother you with the 17 very detailed anatomical features and stuff. And this is it. I want to thank the organization committee for the opportunity to make this presentation and talk to you about pterosaurs. I want to thank my funding agency. I want to thank the Iwaki Museum for access to the specimens. And for the other holotypes, I want to thank the National Museum and the Earth Science Museum in Rio. Thank you so much.
Thank you, Rodrigo. We have two people already. Okay, first here, Alex as first.
Thank you, Rodrigo. Thank you, Fabiana, for this very interesting presentation. I just have to point out actually two things. I have a scientific question and just a comment. So I'll start with the comment first. When we saw that specimen first, back in 90, whatever, we had all the pictures, we had all the information, we had the paper written, but we posed a condition. If the specimen was outside of Brazil, and we said we're only going to publish if they give us a cast. It's not a holotype. I will not go into the specifics. Of course, it's an unlost specimen. It was smuggled. There's no other way those specimens can come out. We all know that. But at least a cast, So since they were not willing to do that, we decided not to describe it. Okay, I know other people have done, So the only thing I would like to comment to you, it would be really nice to tell them, look, we need a cast. That's the minimum you can do. And now the scientific question. The scientific question is, I haven't really followed. Do you think the Iwaki specimen is not leonardi?
Is this working? Hello. So I'm going to start with the last question because it's the most fresh one. I think that it is that the two species could be the same, and in this case it would be Longiclistatus because it has precedence. But I think that it is the Iwaki specimen. That's not a question.
My question is the holotype of Tuposhara leonardi is one specimen, and we referred the Iwaki specimen to that species. Do you think the material, the holotype of the leonardi is a different species or is, from?
No, it's not what I meant. I meant that the three specimens could be the same species.
Okay, good.
All three specimens.
Okay, good. And I have no problem I mean, just to know, I mean, if things evolve and you can then prove or show that you have that difference. However, be aware that they are of very similar size. You will have to deal with that as well.
I have thought about that. Thank you very much for commenting that. And you as a person is a very good example of individual variation, because you yourself are a very tall male. And when we take into account individual variations, we can compare you with the very short females. So I think that this kind of thing could happen to pterosaurs, because it happens not only to humans, but it happens to animals overall. Why this long face? I'm very serious. Did you understand what I'm trying to say? I will try to use other words. The size variation is not a very good proxy for ontogenetic stage, because you have to take into account the individual variation and the sexual dimorphism. So maybe young, small females could be like half the size of the very large males and stuff like that.
I will not enter the debate, but what you just said, you can say for anything.
That's my point, yes.
The problem is how you prove it. In order to say that you have individual variation, in order if you say you have variation due to sexual dimorphism, you must have at least a population that you can express that. And the only thing I can tell you is that each time when we had something like that, there are marked, there are only 2 occasions where we saw it, because I don't know why pterosaurs people haven't come up with that. And in those 2 occasions, we can only express that size, yes, is the best we can go in terms of ontogenetic variation. If we could cut up all the specimens, yes. But I just want to call your attention. We can say anything, but to prove it, it's something different.
I agree. I think the problem is that because of these situations, we can't say that they are not the same species, and this is a problem. If this is a problem towards saying that they are different, and this is the main message I was trying to point out.
Thank you, Rodrigo. I don't think we have more time for questions.
Thank you so much.
So the next presenter, Lucas Antonietto, and the title of his presentation is The Role of Pterosaurs of Romualdo Formation Brazil as Mesopredators based on results of mercury bioaccumulation through the paleotrophic web.
I think we're good now. All right. Hi, everyone. Good morning. So I think we're going to diverge a little bit of what you guys are usually discussing around this event. And I'm going to talk a little bit about pterosaurs ecology and also the ecology of other groups because this is my thing. But first, I think I have to talk a little bit about myself because most of you guys have probably never seen me before, at least at your symposia. I'm an ostracidologist, so I work with very small stuff that we find in very different ways from pterosaurs. And I think some of the approaches we have with ostracods might, I don't know, help you guys a little bit studying all of your stuff. And I'm going to start talking a little bit about what ostracods are and how we work with them. And first, I would like to point that we work with a huge diversity. So ostracods have many, many more species than pterosaurs. Sorry for that, guys. And because we have so many species to work with, and because usually when we find one ostracods, we can find lots of them. It's very easy for us to study fossil populations, and when you have populations available to study, you can study their ecology. And once you start studying their ecology, you can start reconstructing paleo environments. And I have worked with that approach quite a few times already, but usually doing that through statistical ecology. So this is one of the works we have recently published in ecological indexes coupled with population studies to try to figure out how paleo environments used to be in parts of the United States. And one of the things that I have always noticed that once you start working with ecology of arthropods, geochemistry plays a huge part in trying to reconstruct those environments. So this is what we're trying to do right now with the arthropods we work with. So we're trying to add geochemistry to them. And if any one of you are going to the next Strati 2023, which is going to be in France next month, there's going to be a work on geochemistry of arthropods there, and how that relates to the environments as we currently know them in the Romualdo Formation. So when I was working with geochemistry of arthropods in that scenario, I started seeing that the Romualdo Formation has kind of special setup where we're gonna find very interesting stuff to look at in terms of ecology. So the Romualdo Formation, everybody already knows that by now, has a Lagerstadt. And that Lagerstadt is very diverse and very numerous. And other than very nice looking, beautiful specimens that you can use for taxonomy, you can also use them, some of them that are not used for that, for other stuff. So I'm gonna talk a little bit about the Romualdo, but so far we already know most of the stuff I'm gonna talk about. Still, I think it's important to mention that the Romualdo is seen by most of people working with paleoecology as a type of lagoon paleo environment where you are exactly between continental environments and marine environments. And sometimes it gets more marine, sometimes it gets more continental, and some people even think that sometimes it turns into open sea. I'm not sure if that is true. We don't see that a lot with the arthropods we study, but still you have that type of interpretation. And once it gets linked permanently or quite for a while through the sea, it's done by an open in the Proto-South Atlantic Ocean linking parts of the state of Bahia to the interiors of the northeastern region. And what is important for our work here is that the formation of the Lagerstadt in the Romualdo Formation gives us excellently preserved fossils that come into calcareous concretions. And there are so many of them preserved and in such varied levels of quality of preservation that I started thinking when I was working with the arthropods that maybe we could use some of them to try to understand trophic relations in the time during the deposition of the Romualdo Formation. So I'm bringing this draw to my presentation because, believe it or not, this is the most recent trophic reconstruction of the Araripe Basin. So it's been quite a while. It's been a pre-geochemistry reconstruction of that of the trophic relations, and although it's basically based in morphology of the fossils, it kind of lets some questions to be answered in terms of who is eating who. I mean, we most of the time we accept that the big fish, it's the small fish, and there it goes. But sometimes it's not exactly like that. I mean, think about whales and what they have been eating in the ocean. So sometimes the big guys, even the big flying guys, they could be eating other stuff. And what exactly are they feeding upon? Maybe I'm wrong about this slide, so if anyone wants to correct about, but this is the impression that I have about how people see the pterosaurs of the Araripe Basin in terms of how they feed upon. So there would be some of them being seen as generalist carnivores, so they would be guys that could eat pretty much whatever enters their mouths, and maybe some generalist herbivores, or maybe generalist herbivores and carnivores, who knows? And a huge group of pterosaurs, which based on their morphology, they could be strong piscivores. And so that's what we were initially thinking to test. So can we see, based on geochemistry analysis, if we could differentiate between what everybody's eating? And the element we chose to try to figure that question out is mercury, because mercury bioaccumulates, which basically means that once one species feeds upon others, the ones that is feeding on the top of the chain is going to have most mercury on their tissue, being muscles, bones, whatever. So this work takes a little bit of inspiration in some previous works recently put on the literature on how mercury is being cycled through the environment, and how that affects animal populations. So we have this very recent publication on the bottle group with the crocodilians, and they found very interesting results, but they were pretty much working with 2 or 3 species, and sometimes only with a single one, but in varied ontogenetic stages. And that has led them to various reconstructions of how those environments work. So I thought about trying it out in the Romualdo too. And I think there's a very important reason why we do that beyond morphology, and the reason would be that sometimes morphology doesn't tell the entire story. So a good example of that are these 2 species of tuna, which are like in the same genus, and still they have very different mercury concentrations, because this guy over here feeds primarily in the trophic web. So he's a primary consumer. He's eating small stuff. This guy over here is going all the way down in the ocean and trying to get the big guys. So he's eating the predators of predators. I mean, he is a predator of predators, so he's a hyper predator. And by the way, this one, you can eat it safely. This guy over here, if it gets too old, avoid it. The problem is, to do geochemistry on those fossils, we gotta destroy some of them. And I know you guys from Pterosaurs find that very problematic. So that is why we try to be as picky as we could on the ones we decided to destroy. So I'm gonna give you all you guys a warning. No holotypes were harmed during this work. Okay? So first part of the work is picking specimens without what we call taxonomic potential. So we got fragmented bones, stuff that doesn't look like a new species, and I hope we didn't get anything wrong. But still, we have a very, very small population right now, less than 10. And that was, of course, for the pterosaurs. We mixed that with a bunch of groups where we have relative abundance. So we got Hacolepis, which is a genus of fish with more than 1,000 specimens, only at the Plácido Nuvens Museum. We got Ventifer, which is very, very common around here, and Calamopleuros, which, despite being a predator, also gets preserved pretty commonly. Other than some plant specimens, also from species with a very big recovery here at the Araripe Basin. And then we started doing fragmentations of them using circular saws to try to be the least traumatic possible to them. Once we got the cut samples, they went to the lab back in Fortaleza, and they were macerated, homogenized, and dried, so completely destroyed. And using that powder, we started doing HD measurements to figure out what were the concentrations of mercury in each one of them. And these are technical stuff about the things. I'm not gonna pretend I know a lot about it. The guys in Fortaleza can explain you like in extension, right? Then we got our first results. And the first results seem a little chaotic at first because we were looking at the total concentrations of mercury in the fossils. And sometimes you have to account for environmental contamination by natural factors, which kind of makes those results a little variable if you only look at the fossil. But if you look at the matrix too, you're gonna start making some sense of it. So if you look only at the fossil results, you're still gonna see that that Calamopleuros, which is considered a hypercarnivore of all other fish species based on their morphology, it's gonna be the highest one. So it kind of makes sense, right? But if you go to Hacolepis, which is the smallest of them, like almost fish fry, it's gonna be high too. And what could that be? What is the reason behind that? We are trying to figure out if maybe this has a relation with the wildfires that have already been reported to those to the Romualdo Formation, or maybe to some kind of volcanism, which is the reason they usually give to this high values in places like the Paraná Basin. But honestly, sometimes I feel like it could be the work of what we call around here the fishmen, which are people that used to sell those fossils in kind of a very close past. And they did lots of changes to those fossils, and they made them into products that that sometimes were used by people and then given back to the museum in we don't know what condition. So some of those Hacolepis we took from an ashtray. So imagine people burning stuff over those fishes for quite a while. What was going to happen, right? That is the reason why we started measuring the values in the rocks. Because once you look at the same Hacolepis, the matrix is very, very high in terms of mercury content. And that gave us a reason, fossil rock, very small. But once you look at the Calamopleuros, look at that. You see? That is bioaccumulation. The same goes to most of the groups we look at. Once again, very high Hacolepis, but we look at the reason between them, very, very small. And just getting a little back to Vinctver, for example, it's kind of intermediate. And but when we look at the pterosaurs, which we're thinking like, okay, so we have a bunch of ornithocariforms, and sorry if I'm butchering that name, I'm not familiar to them a lot. It's very low for a fish-eating guy, right? And some of those values are not even that low, but we couldn't get the ratio for them because they didn't have the matrix already. Once again, thanks, Fishman. They took away the matrix of those fossils to expose them, and now we don't have a full record of those guys, but still, we have a very high value here. So maybe there are a couple of guys who could be hyperpredators, or maybe they are too close from the fire. And the same goes to the highest of the ornithocariforms, but look at that. It's very, very low value. Even for the highest of them, it's still very low. So once you plot them into a graph, you're going to see stuff like this. This is Calamopleuros. Look at that. He's the apex predator, right? The producers, which are in the very base of the trophic web, are right here, plants. Primary consumers, also very low. Pterosaurs, also very low. So that's the strong indication that all of those pterosaurs, even the fish-eating ones, are not the greatest predators. I mean, they're eating small stuff. They're like flying whales and stuff like that. They're probably eating something between those hycolaps, which used to form huge groups, and they would be kind of easy bycatch. So I kind of see a point in that. Instead of like trying to get a Calamopleuros or something like that, which is going to be a very, very hard task. So in conclusion, the pterosaurs, although we don't have a lot of them, so we can differentiate a lot between the groups. I mean, we didn't have a single tapejarine in this work so far. We got an interrogated Tupuchuara, so the sarcoids are pretty underrepresented too. And even the ornithocariforms, we only have 2. So not a lot. But still, results we have so far point out 2 pterosaurs being primary consumers too, feeding mostly on guys like Rhacholapis and staying away from guys like Cladocyclus, you know. And that reinforces their work in this trophic web as very similar to guys in the very base of the trophic web. So they're not the apex predators around here. So far, the results we have, as you guys already saw, are very preliminary. And I think there's a ton of stuff to do in the future. And one of the things we definitely have to do is do more fossils. So we already have some stuff in Fortaleza right now being tested in terms of mollusks. We got some turtles too. And Cladocyclus, we're going to start working on them right now too. And some of those other groups, we're on the verge of already getting the first results. So I hope I have some nice stuff once the next months come by. But some groups, unfortunately, are kind of hard to get. So terrestrial reptiles like crocodilians and all of that, we don't have them. And there's a strong chance we won't because they're not that numerous after all. So. And the same goes, for example, for echinoderms, which would be very basal in the chain, probably even more basal than the fish. And I think it's a pretty important group to include here. Some of you may be asking why not ostracods. They are just as small. We can get them off the rocks in a very pristine state. So once we work with, we wanted to work with them, we just couldn't get them for that kind of work. And other thing that we want to work in the future is finding something to do with the possible pollution signals. So you saw that some of them might be facing very harsh environmental conditions based on the amount of mercury they have. And could it be another evidence of the wildfires that people have terrorized based on the burnt fossils? I hope we can help with that. And the third thing I think it's important is look elsewhere. I mean, there are places where the tapejanians are very common, like the Cemitério dos Pterossauros in Cruzeiro do Oeste. And why not trying to do something with them? And I want to finish my presentation paying a little homage to a friend of mine, Patrick Getty. He was a good friend. He took some of the pictures. Some of the best pictures I ever had in a field trip. And unfortunately, he left us too soon. Thank you very much.
Thank you, Lucas, for your presentation. Do we have questions? Quite a few.
Two questions. One, can you go back to the slide that had your stats? Keep going. Yeah, right there. So for the fish, the Cladomoplurus, it looks like that one is quite a bit of an outlier compared to the other two. Is that statistically significant or no?
Yeah, we're treating that as ontogeny. So the smallest ones are gonna prey on small prey, and that's probably the reason why the ones are kind of low.
Okay. But those are different size groups.
Yeah,
Okay.
and the same thing happens to tuna fish. So the smallest tuna fish are gonna have the smallest values, but still when you compare young tuna from one species with the other, the demersal predator is going to have the highest values. So if you look at the ratios of Calamopleuros, it's kind of hard. It's kind of high for if you think of the start of their lives, because these ones are adults and they already have values like that, and these guys are the small guys, and they already have like 1.5. But once they reach adulthood or get kind of old, it gets very, very high.
Okay, yeah, I just saw the 3 and I was like, whoa, that's a way
Yeah,
outlier.
and you see that in the graph too, and we want to fill that void doing more Calamopleuros too. So we already including 2 more in this analysis to see where this graph goes. But it is expected that we see the highest variation in them because of the changes in feeding habits.
Got it, that makes sense. And then back to your work, ostracods. Have the ostracods been an indicator of, would that not help determine how brackish or fresh, or, because most modern ostracods are freshwater, yeah?
So the ostracods, I don't want to spoil a lot because that's our work in France.
Okay.
But so I'm going to talk about the stuff we already seen in the past. I have some works published back in 2012 that show that these ostracods were brackish water. And once you look at their diversity, it's not a typical diversity of sea-like environments. So the groups that were supposed to be there are not there. So we should be looking at what we call the cytherocopines at a higher frequency. And what we actually see there is the cypridocopines, which are the typically freshwater brackish ostracods. And even the cytherocopines we see there, they have been in the past described as cytherocopines trying to invade the brackish waters dominated by cypridocopines.
Great, thank you. Interesting
Yeah.
talk.
Oh, yes, it's really quick. I wonder if you could just get more reliable results by avoiding the fishes that were collected by the fishermen and using the specimens from the controlled excavations?
I will. The reason we use the ones at the museum, it's because I wanted to start the research. So it's stuff that we're like delving into for the very first time. So I went to the easiest ones, and once you get to the museum, you're gonna start seeing lots of automated stuff. I mean, the one we show, sorry, the one we show here, we didn't even use it because you can clearly see this is fabricated by fishermen. And all of this matrix, it's actually concrete. So yeah, we didn't use this one.
No, yeah, I totally get it. You have to begin somewhere. So I think the specimens from the controlled excavations, because you have a lot of things, you actually know which level they come from. So that should really help you pin out where you have some anomalies that could be volcanism or wildfires, because Alamo has everything noted, like the several levels where you find the Romualdo fossils.
Exactly. And by the way, we're calling this a trophic web, but you have to think about it as a 10 million year trophic web, because we're not exactly sure about where everybody was in the rock succession. But still, I think it's very important to bring it because it's a first approach. So the next step would exactly be get more specimens and try to get the ones with the minimal possible controlled level extraction. And then certainly the results would be much, much more precise. Especially the pollution ones. Because if some of those levels are heavily influenced by the wildfires or the volcanism or whatever is going on, or if all of them are influenced by that, we could figure that out if we had the controlled excavation.
Yeah, thank you.
Congratulations, Lucas. It's a nice initiative. I
Thanks.
hope you get more and more results.
I hope I do.
To bring us. I totally agree with Thaisa. The geochemistry analysis must be made from the field directly to the laboratory. So you take the sample, took to the lab, and proceed the analysis to avoid contamination, as you clearly had in your samples. So, and also, if you look at specimens at the same level with a stratigraphic control, you are sure that that you are talking about things that occur in the same times, or even not. We know about the fossilization process, but you avoid the biases of your results. Talking about the volcanisms and wildfires, we do have charcoal evidence in the CRATO formation, but do we have some in the Romualdo? I don't know any.
I remember seeing charcoal exposed at the museum that was embedded in concretion matrix. So I'm pretty sure we could find those wildfires in both the formations. I mean, I know the papers have actually been done mostly in the CRATO formation, but still I don't, especially because the whole duration of the Santana group seems to be quite small in terms of time. So I think that's a possibility, a strong possibility. And there are some fossils in the museum that can corroborate that.
Yeah, you should talk to Flaviana because she made her thesis, PhD thesis on charcoal from Araripe, and she made 2 or 3 controlled excavations in Romualdo that I be part because I was her advisor, and she was looking for this charcoal in the Romualdo. And I don't remember to find them in the places that we made excavations, but the Araripe Basin is huge, so maybe in other parts. So you should talk to her because he had this panel of the wildfires in the Araripe Basin.
I wouldn't be surprised if it was like rarer than the CRATO records, because the environment is less stable. So you have influences from all around, and you don't have a stable lake that lasts for long. Sometimes it is a lagoon, sometimes it's a bunch of rivers. Sometimes it gets a little, my opinion, a little sea in it. And so I think that has a strong influence in deposition of plant material. I mean, the fish are going to be there no matter what, but the plant material, yeah, maybe doesn't get there as much.
Biased. And the last one, sorry guys, it's about methodology. What is the size of your sample? How you have to take from fossils to make this kind of analysis?
Think about them as like a closed fist, so it's like that size. And yeah, there was...
It's huge because I do bone histology. So we take half centimeter, and curators got mad for that. So I
it was like I was getting into the museum and people were hiding the holotypes and all of that because they knew I came for large stuff.
People hide all pterosaurs because they
yeah. So it's kind of complicated. It's a little complicated because of that. They need at least 5 grams of bone, and 5 grams of bones is not a small amount.
It's a lot.
That's why I couldn't get them into the analysis. I mean, we have to separate the ostracods from the matrix. It's already a chemical process, very complicated because everything is calcite. So how you dissolve calcite and preserve calcite at the same time, it's maddening, you know. And other than that, you can do it straight in the concretion because you can discriminate what is ostracod and what I mean, you can discriminate the matrix, but you can't discriminate the ostracod. Start drilling on it, you're gonna mix all of the stuff. So the smallest guys we're doing right now is mollusks, which we also have a lot. So yeah.
Anyone else? So thank you, Lucas. Very good presentation. So following our schedule, now it's the coffee break. We'll be back in 30 minutes.